Hello, class. I received a few questions concerning a few problems from the 4.2 problem set. So let's take a look at question number 3. Looks like you have a pediatrician that wants to determine the relation, if any, between the height of a child and their head circumference. Meaning, does a taller child have a bigger head? Right? Maybe a smaller child has a small head. The pediatrician wants to see if there's some type of relationship. I guess the first question you're asked is the pediatrician wants to use height to predict that circumference. So that means height is the explanatory variable and the circumference is the response variable, right? And think of this as the explanatory variable would be along the x or the horizontal axis, and the response variable would be on the vertical or the y-axis. All right, so you can see the correct answer is the explanatory variable is the height, and the response variable is the circumference. And just a quick tip, I would say if I looked at 100 of these tables, generally the first column is the explanatory variable, and the second column is the response variable. Like 9 out of 10 times, that's just how it's written. So if you panic and you feel like you had to guess, I would almost always guess that the first column was your explanatory and your second would be the response. Think of this as your input and your output, or your x variable and your y variable, and so on. Next, we're asked to draw a scatter diagram. Okay, so if you click on the little table box here, we open in StatCrunch, and here's my data. If you press Stat, and then I want to do regression, simple linear, the height was my x variable, and the y was my head circumference, and I think that's all we need for now. I press compute, and let's make this a little bit bigger. Just bear with me. There's a lot of good stuff in here. Okay, so if you look toward the bottom, you have an arrow. I can click it once, and here's my scatter plot. So notice I have my height on the horizontal axis and my head circumference on the vertical axis. And it looks like the units go from 16.9 to 17 for head and 25 to 27 for height. And that kind of makes sense, right? Height was 25 and change to 27. So you look at my label down here, 25 to 27. And my head went from 16.9 all the way up to 17.5. So when I look at my charts, my options, I can immediately eliminate choice A and B because I have height for my vertical axis, and height should actually be my horizontal axis. So A and B are out because height is on the wrong spot, right? We need height down here, right? Your explanatory variable always goes on the horizontal axis. And then the vertical axis was my head circumference. So again, A and B are incorrect. So my only two choices would be C and D. Now, if you look at my graph, the head circumference goes from 16.9 to 17.5. And if you look on my charts here, this starts at 25 to 28. So C is eliminated. D looks correct, right? The head goes from 16.9 to 17.6. And the height went from 25 and change to almost 28, right? 27 and a half, right? So this D is my correct choice, all right? And again, if you look at my picture and their picture, this looks about right. The next question asks you to compute the linear correlation coefficient. Well, that's actually done for us. If I press the back arrow, this R, correlation coefficient, is my answer. So 0.893 would be my answer. We didn't really have to do any work here. Just round to 3 decimal places. Now, if you felt like you did not want to use StatCrunch to calculate this, there is another way. Let me see if I can pull up a copy of the book. This is page 193 in your book. You can compute this R by performing this calculation. This is very tedious, but you can do it. And here are the explanation of all the variables, right? Simple standard deviation, sample mean of your x and your y variables, and so on. But if you were to compute this, you would end up with, let's see if I can find it again, this value for r, the 0.8930 and so on. So that's letter C. And then you want to know, does a linear relation exist? Yeah. So since r is positive and it's somewhat close to 1, right? The closer we are to 1 or -1 would indicate some type of strong correlation. This looks to be a positive linear correlation. And if you look, question B is yes, there's a positive linear association. That's it. That's problem number 3. If I were to go to number 4, I believe it's pretty much the same steps. You're given data. It looks like we have black bears, and you're asked to determine the explanatory and response variables, and then do a scatter diagram. And again, it looks like you're asked for the linear correlation. So just very quickly, I'm going to do this problem as well. So you guys are getting 2 videos for the price of 1. So I click on the data table, right? There's the length of my bear and the weight of my bear. I click on the table. I'm going to open in StatCrunch. And again, when you press stat, we want regression, simple linear. The x was my length, the weight was my y. Let's make this a little bit bigger. I press compute. And again, if you press this arrow here, you'll see my regression or my scatter plot. And all of the key data is also in here, right? My linear correlation coefficient looks like it's 0.718 and so on. So I can use this to help answer some questions. If I go back to the original problem, it looks like this student had trouble with the linear correlation coefficient. Looks like they entered 0.015, but again, we have the correct answer. Right? It would be 0.7183. If you have to round to 3 decimal places, 0.718 would probably do it. And you look, 0.718. So then they ask you to really think about this. What does this mean? So it says, because the correlation is coefficient is positive, right? This is positive. And the absolute value of the correlation coefficient is greater than the critical value for this data set, a positive linear relation exists. Now, how do you find this critical value for the data set? Well, I think we're given 12 black bears. So here's the critical values table. If I click this table and go down to 12, you'll see I have 0.576. Right? That's my critical values correlation coefficient, 0.576. So when we go back to our problem, we found the R to be 0.718, and our critical value for the data set was 0.576. So since our R was bigger than our critical value, we can say a positive linear relation exists between the weight of the bear and its length. Okay, so that's problems 3 and 4. I hope this is helpful. Thank you for watching.